Hey everyone, so today's lesson is going over the Pythagorean theorem and how to use it and when to use it. So in order to use the Pythagorean theorem, we need to have a right triangle. So that is a triangle with a 90-degree angle. It could be an upside down triangle, something that looks like this, one that looks like this. It really doesn't matter as long as it is a triangle with a 90-degree angle. As long as you have that, you can use the Pythagorean theorem if you need to. If it's a regular triangle, we're not able to use it. All right, so here we have a 90-degree angle. So this is a right triangle. And I just want to talk about the different parts of it so we know how to use A, B, and C and where they go. So the two sides that are on either side of the right angle is called a leg. So this is a leg and this is a leg. Now, it doesn't matter which one's which. Those are both legs. Now, for this word, hypotenuse, that is the side that is always opposite the right angle. That is the longest side of the right triangle, and it always goes across from the right angle. So now, to use the Pythagorean theorem, which is a squared plus b squared equals c squared, we use this to find a missing side of a right triangle. So they'll give you two sides, could be two legs, could be the hypotenuse and a leg, and they'll tell you to find the missing side. So in order to do that, we need to label our sides. So A and B are always going to be the legs. Doesn't matter which one goes where. So we could put A over here and B over here. Could be vice versa. You could put A over here and you could put B over here. Does not matter. But the hypotenuse is always going to be C. That's the longest side, so that's the one that does not change. So here we have A and B and C, so that means the length of this squared plus the length of this leg squared is equal to the hypotenuse squared. So it'll make more sense probably when we do an example, so let's take a look. So this example says find the exact length of the third side. So before I apply my Pythagorean theorem, I'm going to label this triangle so I know what I'm looking for. Also, I'm going to put this, I'm going to put the formula up here so I know where I'm going to plug everything in. So let's start with our legs. Let's label those. I'm going to label this one A. I'm going to label this one B. And then the hypotenuse, like we said before, is always opposite the right angle, so that's going to be C. So we know what A is, we know what B is, but we don't know what C is. So that's the only term that's going to stay a variable. So now I'm going to plug these in. So this is A squared. We know A is equal to 9. So that's 9 squared. Let me make that a little thinner. Plus, now we know our B value is 12. So instead of writing B, I'm going to write 12 equals C squared. Like we said, we don't know what C is, so I'm going to leave it as C. Now we're going to calculate from there. 9 squared is equal to 81 plus 12 squared is equal to 144. And we don't know what C is, so we're going to leave that as C squared. From there, we're going to add these two values, 81 plus 144, and we're going to get 225 equals C squared. Just going to move down a little bit. So we're almost there. But remember, whenever we solve an equation, and I'm going to just move it over here, we want the variable to be by itself. It's not by itself because it has that little 2 there. It has that squared. So we want to get rid of that. So to undo squaring something, you have to square root that term. So we're going to square root, and whatever we do to one side, we do to the other. Now, the square root and the square cancel out. They're inverse operations. So all we're left with is C over here, and then 225 is a perfect square. The square root of 225 is equal to 15. So this is equal to 15. Not the square root of 15, just the number 15. And that's it. That's what C is equal to. So you label your triangle A, B, and C, plug in which terms you know, and solve from there. We're going to take a look at one more example where it's similar, but it's not the exact same thing as this. So I'm going to just move over here. So it's asking the same thing. Find the exact length of the third side. So the first thing I want to do is I want to label A, B, and C. So I'm going to label this one down here, A. So that's a leg. I'm going to label this B because that's also a leg. And then the side that's opposite that right angle is C. That's the hypotenuse. I'm going to write down my formula and solve from there. I'm going to plug in 35 for my A. That's going to be 35 squared plus, I'm going to substitute. Now, we don't know what B is. There's no number next to B, so we're going to leave that alone. So I'm going to leave that as B squared equals, and then we know what C is in this question. We didn't know what it was in the first question, but we do know what it is in this one. And it's 37 squared. Well, 37, and then we square that. So I'm going to square both of these numbers. 35 squared is equal to 1,225. We don't know what B is, so we can't square it, so I'm going to leave it alone. And then I'm going to square 37. That's 1,369. Now we want to solve for B. We're going to use inverse operations. I want to get this 1,225 away from the B, so I'm going to subtract it on both sides. That's going to cancel. Bring down your B squared. And let's subtract these. Let's see what we get. 144. I'm going to just move this over here. So B squared equals 144. Now, just like we did before, we're going to square root both sides. That's the only way to undo that squaring right there. Now, those cancel out, so we're just left with B. And then the square root of 144 is 12. So that is the length of our third side. That's what B is. B is 12. You can always take these numbers and plug them in. So, for example, you could do 35 squared plus 12 squared and see if that is equal to 37 squared. That's a great way to check your work, and in this case, it does check out. All right, so label your triangles first, A, B, and C. Make sure C is always across from the right angle. Plug it into your formula, and then use inverse operations to solve from there. Good luck.